Hello Tachyons, this is Kumar and welcome to the TachyLab. We are doing force and motion and in that we are doing movement and position. This is lecture number 4. Today we are going to discuss about graphs. Yes, graphs plays a very important role in your exams and you will find graphs almost in every chapter. So today we are going to discuss about the graphs in general, but tomorrow in the next class we will be discussing about graphical representation of motion particularly, right? So first of all, why do we need the graphs? Why graphical representation? Because it's very easy to understand that way. It shows the relationships, it shows the patterns and trends which you might miss just looking at the data. But if it is in front of you, you can easily compare and see and support the analysis. Now comes how do you actually draw a graph? See, in any graph, you need to choose variables, that is the x-axis and y-axis, right? You need to have these two axes. So you should know what goes on the x-axis and what goes on the y-axis. Then you need to label with quantity. There has to be quantity, but with units. For example, if it is time, you need to write it in seconds. If it is speed, you need to write it is in meter per second. Otherwise, how would I know? Maybe you are representing in hours and one just represent 1 hour and not 1 second. So units are very important. Then set scale. Choose easy and equal spacing. So suppose if the reading is like 2, 4, 6, 8, then it's better that we go with 2, 4, 6 and 8 and all the even numbers, and rather than representing it with 1, 2, 3, 4, right? Suppose if the data is like 5 second, 10 second, 15 second and 20 seconds. So instead of going like 1, 2, 3, 4, 5, so you see that 5 seconds come here. Then what about the 10th? What about the 15th? Very tough to represent, right? So we'll say that, okay, this one step, this will represent 5. So it will be 5, 10, 15, 20. So this way we will be able to cover the uh, coordinates here, okay? Use data from the table. Join points. Use straight line or smooth line as needed. So all the points that you will be drawing like this, and then you can draw a best fit line. Add title, give a clear heading. So whatever graph is it, you should know if it's a speed time graph or a distance time graph. Always take care of the fact that the graph is neat and clean. Do not make it, just scatter the points, or the points are not clear, or you are just randomly, suppose you put a point which is like wrong and then you are just crossing it. No, don't do that. Don't make it with pen. Make it with pencil and erase it. Keep it clean. And always use a ruler. Do not make a freehand diagram. Okay, so here are the points, and let us draw the graph together and you will be able to know what I'm actually trying to say here. Let me just change the color of my pen. Okay, yes. So x and y axis. Let us draw the axis here. This is x's, right? Let us say this is x and this is y. Now it's not specified what are these quantities. Let us say x represent time in second and let us say y represent distance in meter, right? So you will write here time bracket seconds, and on this side it will be distance in meter. You have to mention the units. Then now you have to start plotting the points here. So first is on x-axis it is 1. So you will move 1. So you see 1, 2, 3, 4, 5. So you can simply say that, okay, this one block from here to here, that represents 1. Okay. So it will be 1, 2, 3, 4, 5, 6. And same way on y-axis it is 5, 10, 15, 20. So if you take 1, 2, 3, 4, 5, you will be able to represent only 1 point. So we'll say, so this is known as scaling. Okay, this is known as scaling, that here one block will represent 5. So we call it scaling. So this represents 5, 10, 15, 20, 25, 30. Now see, the first point is on x-axis you have to move 1 and on y-axis you have to move 5, right? So on x-axis it is 1 and on y-axis it is 5. So this is the point. Then on x-axis it is 2. So you will make this vertical line on 2, and then on y-axis it is 10. So wherever the 10 is, you make this line. So wherever they both are going to intersect, that is your second point. Now for the third one, again same. On 3, you have to draw this vertical line, and then on 15, draw this horizontal line. Wherever they both meet, that is your point. Now you can make a dotted line, or you can just imagine that line. You don't have to draw it. It just I have to explain you. That's why I'm doing this. Same way with the fourth one. This is for 20 seconds, 20 meters and 4 seconds. And same way 25 meter and 5 seconds. And now we can join all these points. The points that we just made, we can draw a best fit line now. See, this green line, that is our data. I hope this is clear to everybody. Now, so what are we going to look in the graph actually? So in graph, there are only two things. One is gradient or the slope, and other is the area under the graph. So we are going to discuss both of them one by one. First, gradient or slope. So slope is going to tell you the steepness or the tilt of the graph, that how much tilted it is. So it will tell us that how one quantity is changing as compared to the other one. For example, if this was time and this was the distance, and these are the two graphs. So you know that, okay, this one is steeper, A is steeper than B. So A is changing more quickly than B, right? So A is changing more quickly than B. So if X is time and Y is distance, so we know A is covering more distance in less time. A covers more distance in less time. So you know that, okay, A is going to be faster. Correct? So this is how you see the graphs. Now, if you're understanding by way of teaching and you are liking it, then do interact with the video. For free notes, you can always go and check the description, and you can also contact us for one-to-one and small group classes. Now, how do we actually find the slope? Formula wise, like, okay, we know that, okay, looking at two graphs, we can compare that, okay, which one is more steeper, which one is less steeper, and you can say that okay, it's faster or slower or whatever. Comparison can be made. But what is the actual value? What is the actual slope? How to find it out? So that is change in y-axis divided by change in x-axis. So you need to take any 2 points. So if this is the graph, so you take any of the 2 points. This is x1, this is x2, this is y1, this is y2. So y2 minus y1 divided by x2 minus x1. And you will get the slope. Now comes area under the graph. See, if you have a particular shape, obviously the area will depend upon that particular shape. But if you have to look at the quantity, that okay, what quantity it is, you simply have to multiply the x-axis and the y-axis. So you will get to know that, okay, what quantity is it giving you? You will get to know it better when we will be doing the motion graphs. But yeah, if you only have to see the quantity, then simply multiply these two, you'll get it. Now suppose if the graph is this way. So you see you are getting a rectangle now, a rectangle shape, right? So how do you find the area of a rectangle? So it is length into breadth. So you'll simply do that. Suppose if you have got a triangle here, like the graph that we did. So you have to find this one, right? So what is the area of a triangle. It is half into base into height. So half into, this is base and this is height. And then we have a trapezium. Right? This is a trapezium. How do you find the area under trapezium? Half into sum of parallel sides. So these are the parallel sides. Okay? And height. Height is this perpendicular distance. I hope area under the graph is also clear. So let us now do one question, a general question, and let's see if we are able to do it and plot it. So again, we have a data point. We will draw the axis. This is x, this is y. So on x-axis, either let us say this is time and this is distance. Time is in second and distance is in meter. So you see x-axis, it is 0, 2, 4, 6, 8, 10. If you are going to take 0, 1, 2, 3, 4, it is going to take a lot of points, right? And a lot of space. So we can do the scaling and we can say that, okay, one block represents how many units? 2 units. So it will start from 0, 2, 4, 6, 8, 10, 12. And this is enough. And same on the y-axis, you can see it is 0, 4, 8, 12, 16 and 20. Again, if we are going to take, suppose one block represents 2. So it will be 0, 2, 4, 6, 8. Again, you have to go till 20. It will take a lot more height now, a lot more points. So again, it is going to take a lot more space and time obviously. But you have to save it. Again, we will do the scaling and we will say that, okay, one block represents 4 units. So it will start from 0. So it will be 4, 8, 8 plus 4, 12, 12 plus 4, 16, 16 plus 4, 20. So it will just stop here. Now we will start plotting the points here. So you see it is 0, 0. So on x-axis 0, on y-axis 0. If x-axis is 2 unit, y-axis is 4. So it is 2, 4. Then x-axis is 4, y is 8. 4, 8. 6, 12. Same way 8 and 16, 10 and 20. And now we can simply join these points. So this is the graph that we got. I hope it's clear. And yes, you have to write the x-axis and y-axis. Obviously, you have to write time. You have to write distance here. But now it is also asking us to find out the gradient and the area under the graph here. So let us find out that also. So for gradient or slope, we know it is y2 minus y1 divided by x2 minus x1. So on the graph, you can take any of the 2 points. So let us go back and see. What 2 points do you want to take? Let us take the 12, 6 and 4, 2. So it will be 12, 6 and 4, 2, right? So it will be 8 divided by 4 and it comes out to be 2. So slope or gradient is 2. And what about the units? It will not have any units here right now. Okay, but because there are no quantities specified as such. But whenever the quantities are specified, for example, if I say that, okay, it is a distance time graph or it's a velocity time graph, then it will matter. So if I say x-axis is time and y-axis is distance, so slope slope is going to be distance by time. So distance is meter and time is second. So the units will be meter per second. So it will become 2 meter per second. So slope is giving us the speed. So we will be discussing this in the motion graphs and this is just an example. Okay. Now comes area. So what kind of shape we had? We had a triangle, right? So half into base into height. Base is 12. And what is the height? Height is 20. No, it is 10 and 20. This is the last point. So I overdo it. You don't need to. This is the last point. So half into base into height. So it is half into 10 into 20. Half into base into height. Half into 10 into 20. So it comes out to be 100. Right? So it is 100. Now again, if we talk about the units, so area under the graph will give you something, will give you some quantity, right? And it is x-axis multiplied by y-axis. So it is going to be time into distance. So time is second, distance is meter. So if you have to write down the units, then it will be 100 meter second, but as such, it does not give you any quantity here. Okay, but this is the way of solving it. Do not get confused. If you have any doubts, you can ask me in the comment box. I'll definitely resolve it. So that was it for today. I hope you actually understood it and keep revising it. In the next class, we'll be covering up the graphical representation of motion. It is going to be a very important lesson. Do join it. Thank you so much.